Okay, guys, so now we are dealing with composite functions. This is now putting two of the things together. So we're still in 10.5, but now we're working with these functions that we did here with the angles, and now we're going to put them together. So they're either going to be asking us for the angle when we see the radians, or they're asking us for the outside measurement when we are looking on the inside. And we're going to work from the inside out on these. So the big thing that we want to remember about this whole process is that we are watching our domains. And that's just saying watch where your function lives, what you're looking for. So we're going to look at this first one that says sine of the inverse sine of 1/2. So we're going to start from the inside. So the inverse sine of 1/2, so the angle where, and like I said, we're working from the inside out. So I'm going to start with this part right here. So I'm going to rewrite that. And I'm going to say that that is the, what did I use for sine? Oh, shoot. Okay. So the inverse sine, oh, blue. So we're keeping a pattern here so you know what you're looking at. Okay. So my inverse sine of 1/2. So if I'm looking at my unit circle, so let's draw our circle. Hold on a sec. Let's draw our circle here with our axes. Oh, that's a horrible circle. Okay, with our axes. And so we're looking at where the y value is 1/2 for the inverse sine. So we're going to be looking here and here. Okay, if we're talking about the inverse of sine, we are only looking at this side of the circle. Since we're only looking at that side of the circle, then we really have sine of, because this inverse sine, this whole thing right here, we're replacing with pi 6. So now I have sine of pi 6. So if I'm looking on my unit circle, sine of pi 6, so I want the y value at pi 6. So my y value at pi 6 is going to be 1/2. This one just so happens to work out that way. But if you're not familiar with your unit circle, this is where you want to make sure that you're checking it to make sure that you're accurate. So here we're going to start from the inside out. So I'm going to start in here first. So I want cosine of 4 pi thirds. So if I'm looking for cosine, since it's giving me the radians, that means it wants the measurement on the outside of the unit circle. So that means I am looking for, and let's draw my circle. Here's my, oh, that's not going to be good. Interesting. Yeah, so there's my circle. Okay, so there's my circle. There's my axes. If I'm talking about cosine, then I'm only dealing with the top half of my circle. I'm only dealing with this part up here. Since I'm only dealing with that part up here, if I'm looking for 4 pi thirds, 4 pi thirds shows up on 2 spots of my unit circle, which is going to be here and here. Since it shows up at those 2 spots on my circle, then I want the one that falls into my shaded area. So I want this one right here, since it falls to my shaded area. So I'm replacing all of this yellow here in the middle for number 2. I'm replacing that with negative 1/2. So what I really have is the inverse cosine of negative 1/2. So this time I'm going to come out with an angle measurement. And so if I'm looking at my unit circle where my cosine is negative 1/2, I'm looking for the y value, well, the x value. So I want to know it. Well, if I was looking for x originally, I'm looking for y now. So then I'm going to find out on my unit circle where it's negative 1/2, and I'm going to come up with 2 pi thirds. And I'll show you on a unit circle in a second. If I'm looking at tangent, same thing. I'm going to work from the inside out. And so I'm going to look to replace this here where I highlighted in yellow. So I want to know where on the unit circle the y value is the square root of 3. So where I find that is going to be at okay, there's my axes. So I'm looking, so for where I have square root of 3, which is going to be pi thirds, if I'm looking for my tangent values. But on tangent, I'm only dealing with this part. Pi thirds shows up here and here. I take that back. Not the bottom one. Over here was the other one. Is where I end up with the negative square root of 3. So this turns into pi thirds. Oh, that should not be that color. It should be purple. So pi thirds is what I replace that with. So I really have tangent of pi thirds, which is just going to give me the square root of 3. I'm not going to have room right there. Hold on. Oh, shoot. So tangent of pi thirds is equal to, sorry, square root of 3. That one just happens to be like the first one and it switches back off. Okay, so I said I'd show you guys this on a unit circle. So let me pull up a unit circle document right quick. So here's my unit circle. And this was just from one set of your notes. So we're going to do let's do tangent. So I'm going to write it in here. Tangent, inverse tangent, square root of 3 is what we're looking for this one. Okay, so I want to know first this yellow part, right? So if I'm looking for my yellow part first, which is the inverse tangent of the square root of 3. So for tangent, where I come up with a positive square root of 3 is here. And the tangent values repeat on the other side. They go down. They go the same way. And so square root of 3 we be here if it's positive, but it would also be here if it was positive. If I'm only focusing on this side of the circle because we're talking inverse tangent, then I want this value here. Well, since they gave me the square root of 3, I want to know this right here. So I'm looking for this value. So that leaves me with this part. So I'm going to take my tangent now. I'm going to say now I have tangent of pi thirds. Well, if I'm looking for tangent of pi thirds, guys, that's just going to be this right here. Okay, these are all just using your unit circle in order to pick apart the pieces that they're asking you for. So that's where you're finding it on your unit circle. Let's go back to the notes. Okay, so now let's look at solving some of them. So it says for composite functions, draw a right triangle, convert the inverse function, and label the triangle. Then determine the value of the trig function, and then determine the domain of the solution. So what we're going to do first is we're going to decide which quadrant we're in. So the first thing I'm going to do is to find what quadrant I'm going to be in. So since it's positive, so since this value right here is positive, I'm going to be in, if I have my circle here, because we're talking tangent, positive is here. So I'm going to be in Q. Ooh, that's horrible. I'm going to be in Q1. And since I'm working with tangent, I'm only focused on this half of the circle. Okay, so now I need a triangle. And so I need tangent, which is opposite over adjacent. And I need my triangle to be in quadrant 1. So if I'm drawing my quadrants here, that means my triangle is going to be coming this way. So there's my origin. I'm coming out 2, and I'm going up 1, connect back to my origin. So I'm looking for the point that I'm looking for that angle, right? They asked me for the angle or yeah. Yeah. And so I want, Lord Jesus, the sine of this triangle because I'm working in the middle first. So I need to find my hypotenuse by finding my r. So your r is equal to the square root of x squared. So 2 squared plus 1 squared. So 2 squared is 4. 1 squared is 1. So 4 plus 1. So r is equal to the square root of 5. So this is the square root of 5. And I want the sine of that triangle. So if I want the sine of this triangle, we're talking about this angle here. And so I want my opposite over my hypotenuse. So then I have sine of theta is equal to 1 over the square root of 5. But I cannot leave my denominator as a square root, so I have to rationalize my denominator, and I multiply both the top and the bottom by the square root of 5, which leaves me with the square root of 5 over 5. This is my answer. Okay, all good on that one. Now let's look at the next one. So now it's telling me I need to do another triangle, but they gave me the tangent again of that triangle. So I need to figure out which quadrant I'm in. I'm talking about the inverse tangent again. And so this time it's negative. So I know that I'm looking at my quadrants here, and I'm worried about my tangent, which is just this side. And this is the positive, and this is the negative. This time I want the negative. So I'm going to be here in Q4. If I'm going to be here in Q4, then that means my triangle needs to drop into Q4. So when I'm drawing my triangle this time, Here I have my axes. My triangle is dropping down. So I've gone over, because tangent is opposite over adjacent. Oops. So I've gone over 3, and I've gone down the negative square root of 3. Connected back to my origin. There's my origin. So now I'm looking at, that's my right angle. And I need to find my hypotenuse, so my R. So my R is equal to the square root of 3 squared plus the negative square root of 3 squared. That's going to give me the square root of 9 minus 3. Oh, it's 9 plus 3 because you square the negative 2, which makes it positive. So it's equal to the square root of 12. So my R is the square root of 12. Okay. So since I now have the square root of 12, I can set up my cosine of that. So now I want the cosine of this triangle. And if I'm talking cosine, we're using this angle here. And I want adjacent over hypotenuse. So my cosine, oh shoot, my cosine of theta is equal to 3 over the square root of 12. We know that we can't leave the square root of 12 down there. So multiply both the top and the bottom by the square root of 12, which leaves me with 3 square root of 12 over 12. Done. Can the square root of 12 be simplified? Well, yeah, it can, but we'll leave it like this. All right. So looking on, there are 4 more examples. I'll load the notes with the answers to those examples. But I want you guys to quick check yourselves. What does that mean if you're not one of my students, if you're one of Mr. Cook's students or any other Algebra 2 student watching the video? Quick check means we're going to test your skills that you just learned. So you're going to test your skills on this one, this one, this one, and this one. And what'll happen is I will, when you go look at this video, I'll also use a link to show you the answers to those. So if you're watching the video, I will put a link in the comments so that you can see the answers to those. And rock out.